Thank you for the introduction. Yes, my name is Paul, sometimes known as Stingray. I work in Google, but unfortunately, well, this talk, it's not a Google talk, and it's all about, it's all my own opinions, not Google's. And it's, yeah, I'm pretty sure some of you also share the same opinions, so let's try checking it. So we all like our configuration, right? We use configuration to define the behavior of our programs. It's an important part of our job, of course. And for some reason, we actually rarely like it. So for the next 15 minutes, I will be trying to pinpoint the reasons why configuration management is such a pain. And is it possible to make configuration languages to be not a problem, but a solution? Right? I'm going to try using very old systems to prove some points and draw some unsubstantiated conclusions and provide some helpful suggestions. So let's start. So what do we usually start with? We start with writing some code. So I'm going to write some program, like it's my program, and some offset is a configuration. So I'm going to obviously write more. And then I will try to make the program reusable. So because for it to be helpful, someone else needs to be running it. So they need to change those values. So what I'm going to do, I'm going to put them in a header file, and I'm going to ask everyone to recompile my program. That's totally useful, right? Well, not really. So it's not user-friendly. So which options do I have now? I'm gonna put all my values in the, I don't know, simple file, like an E file, right? It's a very simple data structure. It's just a key value in a text file. So what can go wrong? I don't need to evaluate it. I can just read it. Well, parse it a little bit, find where the equal sign is. The more modern version is this, right? So this is what I'm gonna put my configuration in. It's YAML, right? Also, in this specific example, I am not exactly having a program that uses those values. I'm instructing my cloud to change the behavior, but it's really the same, right? So not a big difference here. It's a key value store, weird keys, normal values. So the problem, well, then I will start to evolve my config, obviously. Right? Because I will need more values. I will need like different structure in my values. Somehow I will start having values that will depend on other values. Some of my constants that I redefine, those will be actually booleans that will turn on and off certain branches in my program. I will need to stick repeated structured values in the config. So this evolution continues, and if I am a person with excellent foresight, at some point I will have a list of considerations, not unlike the list that you will see. And guided by this list, I will develop a future-proof configuration format and structure. And that's what I'm supposed to do because I have perfect foresight, as you'll know. But that is not what I really gonna do. In reality, I will look at the options which are close to me, which is lying on the floor, and then I will take it, and this will be my configuration engine. Or I will look at what is easier to implement. I will, and sometimes I will say, okay, I don't know what the user will need, so I'm just gonna give the user ultimate flexibility, right? That's the thing. Ultimate flexibility, no limits, just do it. And somehow, I will end up, and this is the prediction, this is like, I predict that we will end up with the DSL with the strange semantics. We will have the configuration which must have a lot of options set, so there is no empty configuration. You can no longer run with empty file, like it's impossible. You just need to have 100 values set in there. Not all combinations of options will be valid. You'll have like 200 of them, but you know, if you put 5 here, this must be between 8 and 15. And you might also have more than one DSL in the same file maybe, or files next to the same file, right? Okay, let's go into examples because this is all boring and examples are fun, right? Of course. This is, I think, the most funny example I could find. It's sendmail. How many people have actually used sendmail? That is great. This is probably the best audience to ask this question. All right, so I will skip for those who don't know, and this is probably familiar. Some of you can say what it is. All right, so, it's like the deliver mail was developed in 1979. I was born in anyway, that's my birthday present. I have to run with it. But this is the config, right? You look at this wonder, right? There are actually tabs. Like it matters if some of those are tabs and spaces, but again, some of you might know this. It was a bastard operator from hell badge to wear proudly if you can write those configs from scratch or modify them in any meaningful way. The default configs would be between 1500 and 2000 lines, and it might have comments. And there is an actual syntax, so it's not all garbage. There is a syntax. You can go and into sendmail read cf.c, and there is a comment, and you can read it, and then there is some C code that reads it. And at the time it was written, it wasn't an option to link a library and get any file processing for free, right? You just don't have it. There weren't, I don't think there were even commonly recognized configuration file format. Everybody was inventing things, and it had to be written from scratch, and it had to be easy to implement in C, right? So, and it is a DSL in itself, but also what you see in H lines and R lines is DSL, are two different DSLs in itself. And the rewrite rules, R lines, they have flow control. You can jump between rewrite rules. It's crazy. So this is the reality slide that I showed. Without prior art, it is optimized for simplicity of parsing in C and flexibility of the rewrite rules. So humans need to deal with this somehow. And well, fortunately, whoever wrote this, they thought about humans, so they brought in something else. This is the actual configuration that some of you would write. Like no sane person would do sendmail.cf. Everybody would do sendmail.mc. And this is sendmail.mc. I also have a typo in there, which is significant. Anyway, so this is a DSL written on top of M4, and you already heard about M4 in one of the sessions this morning, right? This was a macro processor. And that is what was chosen to be the high-level language here. Now, M4 is a text-based macro expansion language. It is like, it predates me, so that's fine. It has like a free-form syntax as opposed to line-based syntax. There is a Wikipedia article that lists some of those points, but it is still widely used, which is crazy, in C Linux. I think this is one of the reasons why people disable C Linux all the time. And it works like this. It just takes the token, looks it up in translation table. If there is a match, it executes it. So it like expands it. If there is no match, it just emits it into the output. Now, guess where the problem is? In the previous slide, I typed defune instead of define. So instead of altering the behavior, instead of setting this variable that I'm setting, it just emitted it into the output, right? And it never shows you any error. The error you will see if you try to, sometimes you will see it if it is egregiously wrong and you try to run sendmail with it. Anyway, so that's the thing. To alter the behavior of defined macros, you can change the definition of tokens used in those macros. This is like, well, this is what it is, but basically there are no variables. It's not function calls. You have some macro which uses some tokens, and then you define those tokens, and it's kind of this type of programming that we all love, where you change something and something else suddenly changes somewhere else. So, all right. So what we have is a complete example of a configurable system, which is the base program, which you don't need to recompile. There is a layer 0 configuration language, which is very hard to work with. Layer 1 configuration language that is supposed to be easy, and what makes it problematic. And also, this looks like a modern system all the time, right? I mean, what are the problems, right? I mean, we all think that we know. So let's try to enumerate them. So layer 0, as I said, simple to evaluate, hard to maintain. We have a lot of values. There are no sane defaults. Even the values that you don't need to specialize, you need to specify them. Like M4 kind of hides it for you. It produces this long config, but you need to specify them. It's almost like you have a function with 100 parameters, and you need to specify all of them. And there are 3 pages of documentation describing how those parameters interact and need to be set relative to each other. And you know that if you violate that constraint, you'll get undefined behavior, which we'll like. So it almost looks like layer 0 being optimized for simplicity of machine consumption is not very much aligned with the problem domain, which is the configuration for the mail server. I don't want to write rules. I want my mail to flow, right? So how do I solve it? By giving the user ultimate flexibility, of course. I just put in a program for every call. So I invent a DSL, I call it header substitution and rewrite rules, and I just put it there and basically say, okay, for every single TCP connection, we're gonna, split the input by lines and run those substitutions. That's how we go, right? Also, there are no defaults there, of course, right? So you cannot run it with empty substitution. Like you need to define our rules, and there are special magic rules that they're like numbered. I think like rule 3 is bounce, but I'm not sure. Somebody might know that. Okay, so actually the other thing that I like getting a little bit ahead of myself, if you ever worked with Varnish, that's another basically a wonderful piece of software. It translates the config into C, compiles it, then makes a shared object, loads it, and then executes it on every request. That's wonderful. In the modern approach, you'll just use Lua or Python or Go text template to process that. So it's a template, so okay, now go to layer 1. M4 based, template language with layering violation, right? There isn't a syntax. Typos and errors, they just sneaking into the output. You have no type checking for parameters. You have overrides which just modify the behavior of some other program. It's like one of the most efficient ways to introduce technical debt that I know. It is an equivalent of if you want to write your program, you load someone else's program and then modify bytes in memory. You know the offset, so you modify bytes in memory. Obviously, when that original program changes, all your modifications, they undefined behavior now. But in the moment, it works. In the moment, M4 also works. So, right, so let's go to modern times. 40 years after the events we just described, do we do differently? Do we do better? No, we don't. No, we don't. See how creatively the white space is handled. An indent 4. That's the creativity, right? Of course, this stems from the fact that Go templates have no idea about the structure of YAML, just even the structure of YAML and white space. I'm not even talking about knowing the structure of an object you try to define with that YAML, right? What is semantically valid, not syntactically. Okay. So how everything becomes terrible? Now, summary. The configuration surpasses the stage where simple values is enough. Then we have no sane defaults. So then we make it the result of evaluation of the program. We invent a couple of DSLs for that. We add programs that will execute for every request. And also the configuration that we end up with that doesn't fit the problem domain. So we fix problems by adding more DSLs that are supposed to match the problem domain and just generate this configs, right? So, right. It is, if only we could approach it as a software engineering problem, right? Configuration as a code. Everybody heard this. We tend to store configuration in the source control systems now. We try to do staged pushes and try to do rollbacks. And for some reason, we think that configuration pushes and rollbacks should work faster than binary, right? Which is especially funny if we consider that we insert programs. The most important parts of business logic sometimes are the programs in your config, and it has no tests, and it is written in untyped language. And yeah, I guess no surprise that we don't, we sometimes don't like it. So anyway, our understanding of the things expected from the programming toolkit has changed over the 40 years. Now it is almost unthinkable to run without like continuous integration, continuous development, but not for configs. also, you might have your base program tested well, but the config, where is the testing for that? One thing that I'd like to look at this problem as is an API design program. Let's imagine that our main program is like a main function. Our base program is a main function. And our config is arguments. And we just add more arguments. And then some of the arguments are, as I already said, they start depending on each other. Then we start passing functions as an arguments to be called. And also our function that we deal with rarely returns proper errors. It just throws something in the air. So how would you deal with this if it is an API design problem? How do you fix it? And obviously, one thing that I also mentioned, if it's an API design problem, that Hiram's law applies. Right? Obviously, if you don't know what Hiram's law is, it has its own wiki page. Right, so bottom line, what can we do about this? I described all weirdness, right? All badness. Now, how can we fix it? And it's not like complete list, but it's some list, all right? This, how do you fix it depends on which part of the system do you control, right? So it's a different answer if you control the software or not. So if you do control the software, what I'm proposing is that you try to catch yourself in the act, right? You recognize the point where configuration evolves from having being a simple list of strings or ints or whatnot into more complex structure with dependencies probably. And when this happens, instead of having a pre-processing layer that generates it or a templating layer that generates it, right? Try to think what the real API is, right? And try to build up a structure, right? Like real API that matches the problem domain. Not a generic server that handles TCP connection, but a mail server. Not a template generator to generate YAML, but something that is capable of understanding the structure, like structured values that you're producing, right? The configuration structure is ultimately your API. And if every user needs to interact with API through a layered cake of DSL, it means that there is a bunch of abstractions that your API is missing. You don't know how users are using your software. The users are re-implementing crucial parts of business logic into their layers. Everyone maybe slightly differently, but if no one is capable of just running it with bare configuration, if everyone has to have a layer, you're doing something wrong. I mean, if I am writing the software and this happens, I am doing something wrong. Well, you lost ownership of the problem space, essentially, right? So approach this as you would approach the API design. Everybody try to refactor the functions, so you have same defaults for everything, make simplified variants for the functions. Maybe you need to have more than one entry point, more than one way of defining config. You can still have a config with the 200 parameters, but you can have a config which is part of the base system, not like edit as a layer, for a simple use case, or maybe 2 or 3 of them, or 5. And please enforce encapsulation between simple and complex variants. So, because as I said, it's the easiest way of adding technical debt if you don't have that. If you can specify something high level and then slightly modify it directly in memory to, don't expose internal computation steps. Avoid embedded programs, hooks like a plague. I will skip the slide because I mean it's obvious, like you will find it. And if you don't control the program or having generator is not available, instead of text templates, use something else. Use like structured generation of some sorts and minimize the number of options. Build a testing environment which allows you for all changes to be tested and the entire option space, please test it. Make sure that you can trace every single output line to the input that it changes. Right? Okay, so I have a short postscriptum which is just 10 seconds. I have submitted my talk and 2 weeks later, Jos Visser wrote this. 2 weeks later, right? Then the talk was accepted, thank you. 2 weeks ago, Matt Proud wrote this. Right? It's a hot topic. It was even mentioned in passing in the keynote. What should we do about it? Can we solve it? I don't think we can solve it easily. It wasn't solved for 40 years. But please, let's try doing it. Maybe right now is the time. Continuous integration wasn't solved in a while as well, right? But somehow we managed to get it. Somehow we do it now. If there are two main takeaways for me in this research is, again, we keep making the same mistakes as we did 30 years ago, but maybe we can fix it. Please treat the configuration as part of the system and not something applied by the user, right? Anyway, I don't have a paper to accompany this talk. I'm happy to answer all the questions. Please read Jos's article if you want. That's all about the same. Thank you very much.